Alrighty, 6.7. Today's goal is to write an equation given zeros of a function. Okay, we got what's called the root theorem. F of x is equal to x squared minus the sum of x plus the product. Okay, with that, we're going to be using two of our zeros to help us write that quadratic from those two given zeros. We'll get to that here in a second. But first example. So write a polynomial function of least degree with a leading coefficient of 1 and the following zeros. Okay, so if you remember when we modeled quadratics, it was f of x is equal to x minus p times x minus q, where we just plugged the zeros into there. Okay, we're going to use that same idea, but now, okay, we could have more than two zeros. Like in this case, we have 3. Okay, so what we're going to do is you're going to write those zeros and replace them in with P, Q, and Z. Okay, so you always can write a 0 as a factor. So in this case, it's going to be x minus 1, x minus negative 4, and x minus 5. Now, what's going to be easier is if we write x minus negative 4 as x plus 4. Now, with these, we're writing a polynomial, so we need to multiply this out. Now, multiply it out. Again, it does not matter which order you do it in, but we are foiling. Okay, so I'm going to multiply those first two, and I will get x squared plus 4x minus x minus 4. We still have that x minus 5. Okay, so then simplifying, x squared plus 3x minus 4. Okay, and we still have one thing to multiply. Okay, we need to multiply that trinomial times that binomial. So that x squared to both terms in the binomial, we're going to get x cubed minus 5x squared. Okay, good with the x squared. Okay, distributing that 3x, we got plus 3x squared minus 15x. Good with the 3x, and then finally multiplying that negative 4 through, negative 4x plus 20. Okay, so then finally combining like terms, x cubed, we got negative 2x squared minus 19x plus 20. Now we are writing a polynomial function, therefore since it is a function, we need to write f of x equals, okay, or y equals, either way. So what it comes down to is writing those zeros as factors, multiplying those factors out, and then writing it as a function. Now, I mentioned the root theorem. Okay, given two roots of the quadratic function, the equation can be determined by x squared minus the sum of x plus the product. Okay, so what you're going to do is you're going to pick two of those zeros. So let's do that same exact example. Okay, we got zeros of 1, negative 4, and 5. So what you're going to do, okay, we will have a cubic function in this case. So for this root theorem, you're just going to pick two of them. Okay, and you're going to get the quadratic from those two. So if I was to pick these two, the sum, okay, 1 plus negative 4, you get negative 3. The product, okay, that's saying 1 times negative 4, which gives us negative 4. So from those two zeros, okay, it's always x squared minus the sum, so minus negative 3, so plus 3x, and then plus the product, so minus 4. Now the big thing a lot of people forget, it's minus the sum plus the product. So remember, minus the sum plus the product. So x squared plus 3x minus 4. Now, we still have that x minus 5. We did the sum and product rule with the 1 and negative 4, so we still need to have it with that negative 5. And then again, just multiply that out, and what you're going to notice, x squared plus 3x minus 4, x squared plus 3x minus 4. So really what it is, it's just like a quicker way of multiplying out those two binomials of x minus 1, x plus 4. Okay, so if you don't want to use that, you don't have to, but it is going to be much quicker, and especially once we get into having imaginary roots, it's going to be much, much easier. Okay, so just remember x squared minus the sum of x plus the product. Okay, so let's move into one where we do have an imaginary. Okay, so write a polynomial function of least degree that has real coefficients, a leading coefficient of 1 and 1, a leading coefficient of 1 and 1, negative 2 plus I as 0. Okay, so that first one is kind of confusing. That's our leading coefficient, and we have zeros of 1, zeros of negative 2 plus I as zeros. Now, what you need to remember is imaginary solutions always come as conjugate pairs. So if negative 2 plus I is a solution, or a 0, that means negative 2 minus I has to be a solution as well. Okay, so if you go the long route, you're going to write it out. You get y is equal to x minus 1. It's easy to write out that factor. Now the next one is x minus negative 2 plus I, x minus negative 2 minus I. Okay, just looking at that, that is something I do not want to multiply out. It is possible, but it's a lot harder than just using our sum and product. Okay, so in this case, again, when we use the sum and product, we're going to pick two zeros. I'm going to pick the two imaginaries. So negative 2 minus I, negative 2 plus I. And again, we're doing the sum, so we're going to add those two. Negative 2 plus negative 2 is 4. Negative I plus I is 0. Okay, so the sum is always just going to be adding those real parts of the imaginary, or real parts of that complex. Okay, so product then, let's say negative 2 plus I times negative 2 minus I. Okay, so then foiling that out, we're going to get 4 plus 2i minus 2i minus I squared. Okay, they're conjugates, so when you multiply, the i's are going to go away. And if you remember, I squared is negative 1, so we're going to replace I squared with negative 1. So this is saying 4 plus 1, which is 5. Okay, so we have a sum of negative 4 and a product of 5. So what we really basically did is we just multiplied this part out. Okay, those two factors. So we still got that x minus 1. But then, if we were to multiply those last two factors out, again, x squared minus the sum, which was negative 4, so minus negative 4, so plus 4x, plus the product, which was 5. Okay, so what that root theorem really does is it helps us multiply these two factors out a lot easier. Okay, so we're not completed with this problem yet. We still need to multiply that binomial and that trinomial out. Whoop. So when I do that, y is equal to distributing that x. We're going to get x cubed plus 4x squared plus 5x. That's me distributing that x through. Okay, distributing the negative 1 through. That's going to be minus x squared minus 4x minus 5. Finally, combining like terms, y is equal to that x cubed. Combining our x squared terms, we're going to get plus 3x squared plus x. 5x minus 4x is x. And finally, minus 5. Okay, so that sum and product rule is really going to help us out when we get imaginary roots. All right, so for this one, write a polynomial function of least degree with a leading coefficient of 1 and the following zeros. So we got x is equal to 2. We got x equals 3. X equals negative 3i, which is imaginary, so we need the conjugate of that, which will be positive 3i. Okay, so if we were to go do this and just write out its factors, you get y is equal to x minus 2 times x minus 3 times x plus 3i times x minus 3i. Okay, so you do have the option of just multiplying that all out, but I'm going to use the sum and product. Okay, so for the sum and product, first sum and product, I'm going to use that. We'll go off to the side here. The sum, that's negative 3i plus 3i, which is equal to 0. Okay, product then, negative 3i times 3i will give us 3 times negative 3 is negative 9. I times I is I squared, which is saying negative 9 times negative 1, or 9. Okay, so for the x plus 3i times x minus 3i, x squared minus the sum, which is 0. Okay, so we don't even need to worry about that, plus the product, so x squared plus 9. Now, since there is 4 zeros, we can actually use this root theorem, or I'll say it as the sum and product rule, twice. So let's go ahead, let's use it. Let's do that sum and product rule in purple there with the 2 and 3. Okay, sum of 2 and 3, 2 plus 3 is 5. Product, 2 times 3 is 6. So when I write out that one, x squared minus the sum, which is 5, so minus 5x, plus the product of 6. Okay, so then we got y is equal to that. So again, using that sum and product, all I'm doing is using a nice little trick to multiply that out. Okay, and then the same thing for those imaginary roots. Okay, so it's a lot quicker if you use that sum and product rule. All right, finally we need to multiply that out again. Okay, so distributing that x squared times x squared is x to the 4th. X squared times 9 is 9x squared. Good with the x squared. So negative 5x times x squared minus 5x cubed. Negative 5x times 9 minus 45x. Okay, distributed that. Distribute the 6 now. Plus 6x squared plus 54. Okay, combining like terms finally. Get y is equal to x to the 4th. Okay, looking for my cube terms, I only got the 1. Minus 5x cubed. X squared terms. Okay, 15 total there, so 15x squared minus that 45x plus 54. So there is our polynomial with a leading coefficient of 1 as of least degree. Okay, least degree, there was 4 zeros, so we should have a degree 4 polynomial. All right, so that is 6.7, your homework, page 369. Okay, I have it labeled as 6.7 homework. If you need to check your answers, okay, that is on the 6.7 practice. Okay, so as you're going through, make sure you are checking your answers. If you have any questions, make sure you're asking those in class. Otherwise, have a good day.